In this video, we will be looking at how to factor trinomials, specifically complex trinomials, which are polynomials that have three terms, but what makes it complex is that the coefficient in front of x squared is anything but 1, or technically -1, because a -1 can be common factored out. So this decomposition method can technically be used for any trinomial. However, it is a must for the complex trinomial. So let's take a look. The first thing you want to do when you are factoring a complex trinomial is find some magic numbers. Now, what you're going to have to look at is multiply your outside terms. So 2 times 12 is 24. So we're going to need to find two numbers that have a product of 24, meaning they multiply to 24. And then they're going to add up to the middle term. And it's always going to be like that. Multiply to the outsides, add up to the middle coefficient. Now, we have to think of those magic numbers. So in this case, 8 and 3 would be the only pair that works because 8 times 3 is 24 and 8 plus 3 is 11. Now, the method is called decomposition, so we're going to decompose this middle term into those magic numbers. So we will write 2x squared because we're not changing that, but instead of writing 11x, we're going to write plus 8x plus 3x and then the plus 12 at the end. So those middle terms that we just added in, technically 8x plus 3x is 11x, but me decomposing it or splitting it off into those two magic numbers gives me 4 terms, which means I can now group. So if we think back to greatest common factoring and grouping, we're going to pair up our terms and we're going to find a common factor in each pair. So in 2x squared plus 8x, 2x is a common factor. So I factor out that 2x, and then 2x squared divided by 2x is x, and 8x divided by 2x is 4. In my next pair, between 3x and 12, they have a positive 3 as a common factor, no variable. So I'll write plus 3, and then 3x divided by 3 is x, and 12 divided by 3 is 4. You will know that you have chosen the correct magic numbers and that you've common factored correctly if your two brackets match. If they don't, you made a mistake somewhere. Now that the brackets match, just a refresher, I'm going to write this the long way. We are technically going to use x plus 4 as a common factor. So I'll write that common bracket out, and then in the first pairing, the brackets cancel out and you're left with 2x. In the second pairing, the brackets cancel out and you're left with plus 3. And there you have it. That trinomial turned into two binomials. Also, if you think about when you multiply two binomials and you do distributive property or FOIL, you will remember that whenever we multiplied this setup, we did end up with a trinomial in this x squared x constant format. Now, let's try this again. So 3x squared minus 23x minus 8. We are going to multiply the outsides so that our product is 3 times -8, which is -24, and our sum is the middle number, and we look at the sign, so -23. Now, the product is negative, which means you need a number that is positive and one that is negative. Because the sum is negative, I know that the bigger number will be the negative one, so that the negativity takes over. So our magic numbers here are going to be -24 and 1, because -24 times 1 is -24, and -24 plus 1 is -23. And now we do the decomposition. So 3x squared, and then instead of the middle term, I'm going to write minus 24x plus x minus 8, or you can write plus 1x, whatever works. Now we're back to the grouping. So the newest or hardest part here is coming up with the magic numbers, and having a good grasp on the multiplication table really helps, or else you're just clicking on your calculator until things work, and it's a lot of guess and check, which can be quite time consuming. All right, in our first pair, we have a 3x in common. So when I factor out 3x, I'm left with 3x squared divided by 3x, which is x, and negative 24x divided by 3, which is negative 8. In my first pair, in my second pair, it might look like there's no common factor. And when there's nothing, you have to factor something. So we're going to factor a positive 1. Positive because my first term is positive in that pair. So plus 1, and then we're still left with x minus 8. But now we have those two common brackets, which was the goal. So we write the common bracket, and then we write the leftover monomials in another one, because we know that those brackets would cancel out when we divide out the bracket. And there we have it. All right, for the next one, we're going to multiply our outside. So 6 times 10 is 60. And then the sum is going to be negative 19. Now, it is very important before you start guessing numbers to decide on the signs. My product is positive. In order for me to multiply two numbers to get a positive number, either both of my numbers are positive or they're both negative. To decide on the option, we look at the sum. The sum is negative, which means both of my numbers better be negative in order for me to get that positive positive product and the negative sum. So now we think of different options. And in this scenario, it's going to be negative 15 and negative 4, because if we multiply them, we get positive 60. If we add them, we get the negative 19. And when you write your magic numbers in replacing the middle term, it doesn't matter the order you write them in. So I think the 15 would be nicely paired with the 10. So I'm actually going to write minus 4a first and minus 15a second, but it really doesn't matter. It will work either way. Now we group. In my first pair, between 6 and 4, 2, and then an a. In my second pair, the first term is negative, so I'm going to factor out a negative right away, and it will be a negative 5. So the 2a is out front. 6a squared divided by 2a is 3a. Negative 4a divided by 2a is negative 2. Then I write my negative 5 common factor, and I'm hoping that the bracket will be 3a minus 2, but don't assume that because you might be able to catch a mistake. So negative 15a divided by negative 5 is positive 3a. 10 divided by negative 5 is negative 2. They're matching, so we can write the common bracket out. And then the leftovers. So the 2a and the negative 5. And there it is. And you can always check your work if you have time by doing distributive property here on the side, not as part of your answer here, and see if you end up with your original expression. If you do, that means you did it correctly. But this is your final answer, that bracket. All right. In C, you will notice that there is a coefficient of 1 in front of x squared, which means this is technically not a complex trinomial. There is another faster method to factor this, but that's for another time. So we are going to do decomposition here. If you want, you can write that 1 in front. 1 times negative 24 is negative 24, and then the sum is 5. The product's negative, so right away I need one positive, one negative number. And if I do 8 and negative 3, that would be perfect. All right. Let's decompose. So x squared plus 8x minus 3x minus 24. In my first pair, they just have an x in common. And when I divide out the x, I'm left with x squared divided by x is x. 8x divided by x is 8. And then my next pair, because the first term is negative, I have to factor out a negative. And then 3 is common between the two coefficients. So when I factor out the negative 3, negative 3x divided by negative 3 becomes positive x, and negative 24 divided by negative 3 becomes positive 8. So we have those matching brackets, which is a good sign. And then we can write our matching bracket, and then the x subtract 3 from the GCFs from the two pairs. All right, why don't you try D on your own? So identify your product and sum, find the magic numbers, and then do your grouping from there. Then come back to check your work. Five times 8 is 40, and the sum is going to be negative 22. Because the product is positive, hopefully you realize that both of your numbers should be the same sign. Negative would be ideal here for the sum to be negative as well. So we're going to do negative 20 and negative 2. So 5x squared minus 20x minus 2x plus 8. Pair up your terms, and your first pair has 5x as the common factor, and the second has negative 2. Make sure it's negative or everything will be off with the signs. When I divide out the 5x, we're left with x subtract 4. Write your common factor of negative 2, and you get positive x subtract 4. If you left this as positive 2, your signs would not match because you would write plus 4 and then the brackets wouldn't match. And that would be your clue that, hey, you messed up. Now we can write our common bracket of x minus 4 and then 5x minus 2 for the leftovers. All right. If you got that previous one correct, great. If you made a mistake somewhere, take note of what that mistake was. So in this next one, we're going to be looking for a product of negative 12 and a sum. If you don't see a number there, it is automatically that 1. So a sum of 1. So why don't you pause the video here, try this out, and then come back to check your work. All right, so hopefully for your magic numbers, you said positive 4 and negative 3. You needed one of each to get that negative product. And now we can decompose. So 4x squared plus 4x minus 3x minus 3. In the first pairing, 4x is common. And when we divide 4x squared divided by 4x, we get x. And then 4x divided by itself is 1. And the next pair, negative 3 is your common factor, not just 3. So negative divided by negative becomes positive. And then same thing with the negative 3 divided by itself, we get positive 1. And this is your clue that you did it correctly, the brackets match. So here's our matching bracket. And then for the leftovers, we put the 4x and the negative 3. Okay, from here I have little twists of things we have to be careful of. So for f, you will notice that your first term is negative. You must factor out the negative, just a greatest common factor, before you do any decomposition. You cannot have your first term be negative. So we have to fix that by doing a common factor of negative 1. So we'll have 4x squared subtract 12x plus 9. So it just changes all of the signs. And now we'll keep that common factor out in front, but we do have to do our decomposition. So 4 times 9 gives us a product of 36, and our sum is the negative 12. So our numbers will both have to be negative here, so that they multiply to be positive, but add up to be negative. And the two numbers are actually both negative 6. So keep the negative 1 out in front, and if you want, you can just write it as a negative. That's perfectly fine, and that's how I will write it, but negative 1 is fine as well. So 4x squared subtract 6x 2 times, and then plus 9. The common factor between 4x squared and 6x is 2x. In the next pair, because the first number here in the pair is negative, we're going to take out a negative 3. And again, don't forget about the negative. And here I will open up a square bracket because I will have more brackets inside. So here's the 2x. 4x squared divided by 2x is 2x. Negative 6x divided by 2x is negative 3. And then again, I take out the negative 3. Negative 6x divided by negative 3 becomes positive 2x. 9 divided by negative 3 becomes negative. the brackets match, so I know I chose the right magic numbers. I know I was good with my signs. So here's the common 2x minus 3, and then my other bracket will actually also be 2x minus 3, which you can also write as 2x minus 3 squared, and that would be perfectly fine. There is actually a shortcut that we could have used to factor this expression. It is called a perfect square trinomial, but decomposition works perfectly well as well. All right, for G, you will notice that we have another variable, which normally would be a little bit problematic, but if you notice the symmetry here, if you look at the outsides, both of your variables are squared. And if you look in the middles, you have one of each. So it's like x squared x, no x, no y, y, y squared. They're kind of in ascending order or descending order coming together in the middle. So this is actually fine, and we're going to apply the same decomposition. And I'll show you the only twist, and it's really just about being careful with your variables. So 4 times 7 is 28 for our product, and our sum is 16. So over here, 14 and 2 are perfect. So when we decompose, it's going to be very careful, or it's going to be very important that you're careful here with your variables. The middle term had an xy. So when I do my decomposition, I'm not just going to write plus 2x plus 14x. It's xy. That's the term you're decomposing. I'm going to put the 2 first. So 2xy plus 14xy, and then plus the 7y squared. So whatever you're decomposing, make sure your variables match, and then everything else will be normal. It's really about your attention to detail here. Let's pair up. So 4x squared and 2xy, they both have a 2 in common, and they both have an x in common. And the next one, 14 and 7 are divisible by 7. They don't both have an x, but they both have a y. It's slightly different in terms of there's a y in the mix, but the steps are identical. So we take out our 2x. 4x squared divided by 2x is 2x. 2xy divided by 2x is just y. And then 7y is the common factor for the next pair. 14xy divided by 7y is 2x. 7y squared divided by 7y is y. The brackets are matched. Perfect. So 2x plus y and 2x plus 7y at the start. All right, for H, you might be tempted to go straight to your decomposition, but you actually should not. Your first question should always be about a common factor. And if you look at these terms, the coefficients are not common, but there's an x in each term. So before you do anything, you must factor out that x. And all that's going to do is drop each of your exponents by 1. Now you can do your decomposition. So just like in the example from above where we did a common factor of -1 and we kept the negative from step to step, that's what we're going to do here, and we're going to keep the x in front from each step. So I want you to go ahead and pause this video, identify your product and sum. So 4 times 3 is 12, and your sum is -8. So find your magic numbers, do your decomposition. Just be careful with your communication because you are going to have multiple brackets here. And then come back to check your work. All right, so your magic numbers here are both negative, and they're going to be -6 and -2. So hopefully you kept that x in front. I'm going to put my 2x first. And then in the next one, you're going to open up your square bracket. Your first pair has a 2x, your second pair has a 3 that is negative, because the first term was negative, so that is a place for a common mistake, so check your work there. When we take out the 2x, you should be left with 2x minus 1. When you take out the -3, once again, you should be left with 2x minus 1. Here's the 2x minus 1 common bracket, but notice I remember to keep my x at the beginning, and then 2x minus 3 from those common factors in front. And there it is. Okay, the next one. This one is going to be the last funky one. So you will notice that our exponent is actually a little higher here, but there is no common factor. However, in other examples, we had x squared x constant, and this one it's x4 x squared constant. This is still okay, as long as you have a constant at the end and your middle term is half the exponent, you're good. So this could have been x to the 6, x to the 3 constant, x to the 8, x to the 4 constant. As long as you have that set up, decomposition will work. So just like in the example above, where when we did the decomposition, we kept the xy for the middle term, when you do decomposition here, your decomposition will have x squared for the middle term. So I want you to try this out on your own and then come back to the video to check your work. Just be very careful with the exponents. All right, so our product is going to be 12. Our sum is going to be 7. So 4 and 3 are your magic numbers. Now here is the twist. Check your work to make sure. First of all, make sure you didn't switch the question and put x squared and x throughout. So we have 6x to the 4 plus 4x to the 2 plus 3x2 plus 2. Now it's back to basics. So for 6x to the 4 plus 4x squared, 2x squared is common. For 3x squared and 2, there's actually nothing, but we have to take something out, so positive 1. When I take out 2x squared, we're left with 3x squared plus 2. And then when I take out the 1, we're left with the exact same thing. So 3x squared plus 2, 2x squared plus 1, and there we have it. All right, last one. For this last one, there is a common factor and the first term is negative. So we have to be super careful. Not only can we divide out a 3, because your first term is negative, you have to factor out a negative 3. If you don't, it's not that your final answer will necessarily be wrong or your process is wrong, but you will not have been fully factored. So when we divide by negative 3, we're left with 4x squared, and then negative 3x and negative 1. Now you can do your decomposition in that bracket. So pause the video for your last example. If you made mistakes in previous examples, take note of them and be careful with this last one. Then come back to check your work. So your product is negative 4 and your sum is negative 3. So your numbers are negative 4 and 1. If you struggle with finding the magic numbers, and that's the part that you just get stuck on, but the rest is okay, it's because you don't know your multiplication table. So practicing the multiplication table, doing minute math would really help. So we're going to decompose. So minus 4x plus x minus 1. The first pair has a 4x in common. The second pair has nothing. But you have to write something, so we're going to write plus 1. Make sure you're keeping that negative 3 out in front. If you forget about it, you have completely changed my equation or my expression. So I take out the 4x. 4x squared divided by 4x is x. Negative 4x divided by itself is negative 1. And for the next one, it's the exact same bracket because we're just dividing out a 1. The brackets match. It's a good sign. So here's the common bracket and the original greatest common factor. And then 4x plus 1 for the leftovers. And there you go. That's your decomposition. It will work for any trinomial. Just be careful with your signs. Be careful if your brackets don't match. You did something wrong, so don't let it go. Find your mistake. It could have been your magic numbers were wrong or your signs. Something went off there. But there we go. That's how you factor any trinomial.